Hello everyone. Welcome to the interaction session for advanced robotics course. So this is just the first week and it would mostly be an introductory session where you'll have different maths questions that will be posing and that are necessary for any uh, application or any problems that you want to deal with in robotics. So it would essentially be a very basic session, but slowly we'll delve deep into different types of, like, you'll start with forward, reverse, and inverse kinematics. Then we are going to have this DH parameters. We will end up with biped locomotion and so. Uh, I am your TA for this course. So I'll be conducting all the interaction sessions for 12 or probably 13 weeks. So I am Soumya and I am a PMRF fellow at IIT Gandhinagar. So if you have any questions throughout the course, if you have problems in doubt solving or problem solving, if you want to clarify any doubts, you will also have to submit assignments now and then. So the questions that I'll be taking up here will be relevant in case you have registered and you want to solve the assignments. Even if you have not registered, it is good for you because you'll be able to learn a lot of things, because exercise is the best session that keeps you in practice, right? Before we move further, I just wanted an introductory session. Uh, it can just be in chat. I just want to know your semester, which college you are from, and like, have you taken any robotics course before this? Because this is an advanced robotics course, so I just want to know the audience. Okay. Okay, then you can write throughout. I'll start with the session as well. Uh, okay. Okay, I'll start. Meanwhile, you can have the answers in the chat. Okay. So I hope everyone went through the very first week lecture, whatever was taught by Professor Ashish. So we'll start with the basic course layout that we are going to have. You might have already seen this, I suppose. And so it would be advisable if you like already go through the week's lecture before coming to the class. Also, if possible, solve the assignments, else I'm here to help you. So the thing is that we are going to have uh, 12 weeks of the session. So 12 interaction lectures will also be there from my side. And you can see very well that the next week only we are going to have this DH parameters and forward and inverse kinematics. So I think up until 6 or 7, no, I guess 8 as well. Up until week 8, you might have learned it already in your basic robotics course as well, right? But after this, Just a second. Yeah, so recording would be available on my YouTube channel. So the thing is that you're already, you might have already been shared a sheet with you, right? So you might have a public sheet with you, a spreadsheet shared, in which there would be a folder link in which the presentation, the recorded slides will be put. So I'll be putting them every week in that folder. Then there will be a column for this YouTube link. So I'll be updating the YouTube link there also. So you'll always be able to have the links there. I think uh, I can post the link here as well. Just a second. Yeah. Yeah. So this link will always be available. So I think it is accessible to everyone. So you will always have the slides, whatever I am teaching, whatever annotations I make to be available, plus the recording as well, which would be uploaded on YouTube, and the links will be available to you in the spreadsheet, right? Okay. It would be good if you attend it online because you'll be able to clarify your doubts. Because if you are going to listen to the recorded lectures, I'll not be able to help you there. If you're in class, we can have an interactive session and you might be able to solve your doubts better, right? So yeah, please try to attend. It would always be on Monday 6 to 8. If there are any changes, it would be intimated to you beforehand. Okay. Okay. So yeah, up until week 8, I guess, is already covered in normal or the basic robotics course as well. These 9, 10, 11, 12, I think would be new for you. Okay. Still, since the course covers everything, so we'll be looking through all of them. Okay. Now, let's start with all the type of robots that we have. It is just a very basic introduction. So we have this hierarchy of classification of robots, right? Like we have manipulators, we have wheeled robots or AMRs, autonomous mobile robots. In autonomous mobile robots, we can also have legged, we can have wheeled robots, right? So the first row that we have consists of all the robots that are mostly manipulators. Manipulators means the base is fixed and the other parts of the robots, the other links that you have for the robots are allowed to move and reach a particular place. So we'll have the questions also. So you might be aware of revolute and prismatic joints, I believe. We'll have them coming, but yeah, all sort of things, those sort of things. Then in wheeled robots, we can have single wheeled, two wheeled, three wheeled, four wheeled, six wheeled, or tracked robots as well. So these wheeled robots face some problems. And can someone answer in which case this wheeled robot is going to face a problem and legged robot would help? Because nowadays, if you are LinkedIn or anywhere, we are seeing everywhere that yeah, these legged robots are coming newly into the picture and they are able to navigate various kind of terrains and they are able to do whatnot. So, how do you think this legged robot helps? Especially quadrupeds, you might have seen unitary quadruped. Then you might have seen, I think, Deep Robot or something is the some Chinese company. It came right now into the picture. Yeah, right. So, legged robots are useful in uneven terrain. So if there is really unstructured terrain where you have high variations in the geography, then in that case, these wheeled robots are not able to remain stable. They may topple off or such situations may happen. So legged robots are helpful there. Mobility is restricted to a particular space, or you mean that legged robots are able to expand themselves? That is not a very strong reason for choosing legged robots, but mobility, I mean, mobility can be provided by both, right? But legged robots have this flexibility of walking on uneven terrains and maintaining the stability. Yeah, yeah, it needs tracks or roads. So off terrain navigation, if one has to go to, anyone would choose legged robots over this, right? Now, in legged robots, so you can see one leg, bipedal. Bipedal are the humanoids. So you might be aware of this adverb, the company which has got in ties with Reliance Industries Limited, and it is making the first humanoid in India. So that's really interesting project. Then this is a tripedal robot. Quadrupeds are the robots which have four legs and they are well into the picture. So in India, I guess we have two or three startups that are making quadrupeds. So they are doing good, but yeah, Chinese robots are somewhat much ahead of us, and we need to work a lot to go or to meet the standards that they have achieved. This is a hexapod, and this if something has many legs. Okay, so there can be swimming robots, there can be flying robots, there can be robotic balls, swarm robots. Swarm robots are the robots in which there are multiple robots and then they want to move in a certain way. So you might have seen the swarm of birds, right? So the pattern in which they move is really, just a second, I'm admitting now and then. Yeah. So after this, we have modular robots. What are modular robots? Anyone? Any idea? In case you want, you can also turn on your mic and speak. I mean, since it is being recorded, the main screen is only being recorded. So if your voice is there, it would be good. No, no, there is no video. It's just a slide. I hope you're able to see my screen. This all type of robot screen. No? Can someone else confirm? Okay. Manmeet, I think there is some glitch on your side. Please check once. Yeah. So these modular robots are essentially the robots which can reconfigure themselves to uh, go through some specific task. For example, you have a robot which is naturally in the form of a quadruped, and then you want that it should have some modularity in it, that when it is needed it behaves like a snake. So in such cases, these modular robots come into picture. Then there are these microbots and nanobots that have come into the pictures. So everything going inside our body for like fighting with some uh, unwanted cells. So for all those reasons, nanobots are already there. So the best example, for the nanobot is TENS that we have when a person is like operated for a heart disease. Then there are soft robots. So this is the area in which I also work. These soft robots are really the ones which have active compliance or passive compliance in them, which means they can deform according to the nature of the environment that is. So if, for example, if there is a highly uneven terrain and there are like blocks of bricks already kept there, so a rigid robot would not be able to adapt to all the surroundings and move forward. So these soft robots help. Then there are snake robots, crawler robots, and hybrid robots. So this is one of the links types of robots. You can see it. For this is for your reference. For example, for aerial operations, you have drones. Then for disaster management, what all robots are used. Then what all humanoids are available. All of these are there at this link. It would be a good read if you want. Okay, coming to the lecture. That was already taught to you. I'm covering the very highlights of the PPT that you have already read. So it would essentially be what all questions that we are going to have and how you're going to solve this week's assignment. Okay. So you can see in the first slide, if you've gone to the lecture, you might be able to recall all of this. That if you have an axis, if you have an axis, which not axis, if you have a coordinate system, let's name it A, and it is placed in this way, x here, y in the vertically upward direction, and z in this direction. And if you rotate it by an angle theta and get the new frame, which is B, okay, and if you're supposed to map the same point between each frame, what is the way you do? Okay, so this is a very simple geometric relation. Just a second. Yeah. So this is a very simple geometric relation in which you can easily see that x is equal to u cos theta minus v sin theta, and y is equal to u sin theta plus v cos theta. So you get this when you are rotating and you apply all the geometric principles, then you get this. This can be represented in the form of a rotation matrix into the coordinate of the point which we get on rotation. So there is a relation between uh, the fixed axis the fixed axis point to that of the rotated frame point, and that is linked by this rotation matrix. All right, so since in this case the rotation is performed about the z axis, we see that z axis should remain constant, right? So we have z and v to be same, and the complete rotation matrix is given by this. This is already there in the lecture. I'll not emphasize a lot on this. The crux of the thing that I'm saying here is that RZ, RY, and RX, these are given by this. It's all a combination of sine and cos. And once you make the derivation, you will not have to remember even, you will always get it through. So it's like you should always be able to write this rotation matrices and be able to map the points from a fixed axis coordinate system to any other rotated axis uh, you get. Before that, the determinant of this matrix is always 1, right? And R transpose is equal to R inverse. Why this is the case? Because rotation matrix is orthogonal matrix. Okay, you can check the orthogonality of the matrix. All the vectors in this matrix, be it row or column, are perpendicular to each other. All right, so you can see this. Yeah, we'll be dealing with problems. Just wait for a while. Okay. Okay, so if you have, apart from rotation, some translation also, then what are we going to get? So the first thing in this, sorry, the first thing we have is this rotation matrix. This part deals with the rotation. This part deals with the translation. The lower part, it remains as 0, 0, 0, and this is 1. So we already had this, but this rotation is taken care into account from here and translation from here. Okay, we'll see the questions. Okay, so if you take the inverse of rotation matrix, it is going to be just R transpose because it is an orthogonal matrix. So this is in an important relation really. The other thing is that for translation, this does not apply. Please do not use it. Okay, for inverse of homogeneous transformation matrix, this is the same relation. R inverse is equal to R transpose. And then for translation, you have to take the inverse, you have to write minus R transpose into whatever translation vector you have. 0, 0, 0 and 1. Okay. Now we'll start with some very basic maths question and then we'll be moving forward. So I think this is a 12th class question and anyone can solve. Yeah, it's a very simple question. Yeah, root 2 is the correct answer. I hope everyone is able to find this answer. Yeah, it is really simple. Okay, I'll explain. But see what we are going to do. Let's say we have a vector a vector which is 3 I cap plus 2 j cap, and b vector which is 2 I cap plus 3 a cap. What are we supposed to do? So this is the position vector of a particle. Position vector of a particle means, what does that mean? So if I draw that, see, uh, let's say I name a vector a vector. It's 3 comma 2 because it's 3 I cap plus 2 j cap. And let's say I name another vector which is a b vector. Okay, so and its position vector is 2 I cap plus 3 j cap. I'll name it j cap, name it I cap. Now if you find the, so this is the coordinate point. I'll change the color. This is the point and this is the point. We are supposed to find the distance, means we are supposed to find this distance. If you remember this uh, vector addition, then what you can write? A vector, let's say I name it d vector, plus d vector is equal to b vector, right? And what am I supposed to find? I am supposed to find d vector. D vector is equal to a vector minus b vector, which is, what is a vector? It is 3 comma 2, 3 and 2 minus 2 and 3. Okay. If you find this, you'll get them to be equal to 1 and minus 1. Uh, since we want to find out what is the distance, we'll take the magnitude of the vector and it is going to be 1 square plus minus 1 square, which is equal to root 2. So root 2 is your answer. I hope it is clear. Please brush up your skills because we'll need them very much when we proceed forward. Okay. Okay. Now, from the figure below, write the expression for the position of point PE, which is written as x comma y in terms of theta 1 and theta 2. So this is a very basic geometry that you're going to apply. I think you'll be able to apply. But let's see, we want to find out what is x and what is y. That means from here it is definite that we somehow want this length and we want this length. This is for sure. And you can check, you can get both these lengths by just doing a simple projection, cos and sine projection. So how we'll do? I'll show you. You should always have a notebook and a pen with you, please. Go on solving as I am also solving. Be proactive in giving the answers. Okay. Okay. So we'll see. I'll write with red. Okay. So before solving anything, let's draw all the perpendiculars because it would be helpful for us, right? So let's say I drop a line from here. Okay. And I drop a line from here as well. So this would help me for sure. If, okay. What would be this? L1 cos theta, right? L1 cos theta 1. Okay. Before that, what would be this angle? Can someone tell me what is this angle?
Forty-five degrees, ma'am.
Why is it 45 degree? You haven't been given anything, no? It's theta 1 and theta 2 only. No, it's not theta 1 plus theta 2. I'm just asking the purple angle, the purple colored.
Ma'am, theta 1.
Yeah,
Theta
it
1.
is. Right, right. It is theta 1. And why is it theta 1?
Ma'am, this is, I think, corresponding angle.
Yeah, corresponding angle, right. So when there are two parallel lines and there is a line that intersects them, then the corresponding angles are equal. So this is theta 1. So this line would be L2 cos theta 1 plus theta 2. Okay. So you found the x coordinate before that. We'll see this also. This is L1 sine theta 1. Why? Because this is L1 sine theta 1, right? This line. So this is also L1 sine theta 1. And this is L2 sine theta 1 plus theta 2. Okay. So from here, you can write x1 is equal to L1 cos theta 1 plus L2 cos theta 1 plus theta 2. And then you can write y, sorry, not x1, y is equal to L1 sine theta 1 plus L2 sine theta 1 plus theta 2. Alright, so the correct option is D. Okay, now I hope everyone is done with this question. I can move forward, right?
Yes, ma'am.
Okay. Okay, let's move to this question. So given x is cos theta 1 plus theta 2 plus cos theta 1 plus theta 2 plus theta 3. Similarly, it goes for y, where you have the same relation in sign. What is the determinant of the matrix J, which is given by J transpose, and J is given by this matrix? We have to also substitute the value of theta 1, theta 2, and theta 3. So this is a basic differentiation question that you should be able to solve. Like, you should be able to differentiate partially with respect to a particular variable, keeping all the other variables constant, right? So, okay, this is x and this is y. Let's go for the first term. What would it would be? I want to just differentiate with respect to theta 1. What would it be? It's very simple.
I think it is minus sine theta 1 minus cos theta 1 plus theta 2 minus sine theta 1 plus theta 2 plus theta 2.
In the second term, how do you get cos? Shouldn't it be just sine only?
No, everything is fine and fine. All in sine.
All in sine, na? Right?
Yes,
Yeah. So it's gonna be minus sine theta 1, because cos theta 1 ka differentiation is minus sine theta, right? For the second term, you are going to differentiate it. It would be minus sine. Just apply chain rule, okay? Sine theta 1 plus theta 2. Now after this, you'll have theta 1 plus theta 2 outside. Differentiate that. Theta 1 ka 1 aa jayega. Theta 2 ke liye it would be 0. So you'll just have this term multiplied by 1. Apply the chain rule, okay? Okay, after
चलो
this. Sorry? Sine theta 1 plus theta 2 plus theta 3. Similarly, del x by del theta 2. Now, the first term, which is cos theta 1, when differentiated with respect to theta 2, would become 0, right? So we won't have the first term. We'll have the second term directly. It will be minus sine theta 1 plus theta 2 minus sine theta 1 plus theta 2 plus theta 3. When you differentiate the third term, you won't have the first differentiation of first and second term. This first term and second term would be 0, right? Because you are differentiating directly with respect to theta 3. So there is so the first and second terms would act as constant and differentiation would be 0. It would just be minus sine theta 1 plus theta 2 plus theta 3. Okay. Similarly, if you try to differentiate this, the differentiation of sine theta is cos theta. You can directly write it. It is very similar to the first part. Please keep on solving because the ultimate answer you are going to only bring it. Theta 1 plus theta 2 plus theta 1 plus theta 2 plus theta 3. Okay, and del y upon del theta 3 is cos of theta 1 plus theta 2 plus theta 3. All right. So you have got all the values. Just substitute it in this J matrix. Substitute the values for theta 1 is equal to 60, theta 2 is 0 and theta 3 is equal to 0. And let me know what is the matrix. Just the J matrix before. I don't want J tilde matrix, just J matrix. Does anyone have the answer? Yeah, I think you'll be able to go. We'll need to just go through the problems of rotation and homogeneous matrix. Sit for the lecture today. We'll have the questions for these as well for rotation and homogeneous matrices. Um, I think you'll be able to understand. If you're able to understand the lecture, it is just going to be simple. And what exact maths knowledge you're talking about, I'm not sure. But yeah, all those things happen with just 12th maths knowledge only. So I think you'll be able to. Okay, does anyone have the answer to this question?
And is it zero?
Sorry?
And the answer is zero.
Answer is zero. Are you, which answer you are talking about?
No,
Is
the options are given, the minus 1, 1, 0, and 2. Actually,
uh,
my matrix
huh,
is
but that is for getting the determinant. Did you reach till the determinant?
actually that j is coming minus 14, minus 14, 14, and 14. And root 3 by 4 is common.
Oh, you have something in common as well. Can you simplify by taking that common inside? Then I
Like,
can tell you.
yeah, minus actually j is equal to, inside this is minus 3 root 3 by 2, then minus 2 root 3 by 2, and minus root 3 by 2. The first row.
Okay.
And the second row is 3 by 2, 1, and 1 by 2.
Yeah, yeah. And if you multiply it with the transpose, the resulting matrix will have a determinant of 0. That's right.
Yes,
Okay. Just a second. I'll write the answers. I'm not writing it in root form. I'm just simplifying it. So I'm giving you the answers. So we are supposed to find J tilde, right? Which is J into J transpose. It would be the multiplication of minus 2.598 minus 1.732 minus 0.866 1.51 0.5 into the transpose of this matrix 32 minus 0.866 1.51 and 0.5. When you multiply both of them, you will get it to be equal to approximately 10.499 minus 6.062 minus 6.062 and 3.5. Check the determinant of this here transpose. You'll get it to be 0. Okay. So this is very simple. This question was mainly based for this, based on this partial differentiation only. You should be aware of this. Okay. Okay. Now let's move on to the fourth question. Solve the relation. The determinant of J is equal to 0 and find the value of theta 2 where J is given by this. So you are basically supposed to solve this matrix determinant to be equal to 0. That's it. So what you are going to write? Determinant of this matrix J that is given to you is equal to 0. If you write the determinant of the matrix, what you're going to get? Please keep solving parallelly. Don't wait for my answers. Yeah. So let's multiply the first and the, I mean, 1 and 2 2. Okay. So it would be sine theta 1 cos theta 1 plus theta 2 plus sine theta 1 plus theta 2 into cos of theta 1 plus theta 2 minus cos of theta 1 sine of theta 1 plus theta 2 minus cos of theta 1 plus theta 2 sine of theta 1 plus theta 2 is equal to 0. Right? These what term cancel out? So what you get is sine theta 1 cos theta 1 plus theta 2 minus cos theta 1 sine theta 1 plus theta 2 is equal to 0. Okay, this is what you get, right? Now, can anyone tell me what you're going to get on the left hand side and right hand side is 0? It is a simple trigonometric identity.
Then angle is 0 actually. This is the
Sorry?
formula. This is the formula of sine A minus B.
Yeah, sine A minus B. Ah,
Sine A
yeah, yeah,
cos B minus cos sine
yeah. So, we know this. Sine A minus B is sine A cos B minus cos A sine B, right? When you put this here, what you'll get? Uh, you'll get sine of theta 1 minus theta 1 minus theta 2, right? So that means minus sine theta 2 is equal to 0. So from here what you can say? Theta 2 can be 0, pi, 2 pi and so on, right? So we can only say, we can say that theta 2 is always, we can say, if we take just one value, we can say it is 0 for any value of theta 1. So whatever value theta 1 has, theta 2 should be 0 if we want to satisfy this equation of j determinant equal to 0. We don't really care what is the value of theta 1. Okay, just theta 2 should have these values. So we can just conclude from here the above equation which we already solved holds for theta 2 is equal to 0 for any value of theta 1. Okay. Okay, I hope this is clear. This was a very simple question. Okay, I hope it is. Let's move to the next question. Okay. Find the vector y in the equation x is equal to r into y, where x is this, r is this. I want to find what is y. So if you're given x is equal to r into y, how would you find y? So what we should do is multiply by an inverse. R inverse x is equal to R inverse R into y. Alright. So from here, and this R inverse R, this complete thing becomes identity matrix. So y is equal to R inverse x. Alright. Now, okay, by looking at the matrix R, can you tell me something? Do you get some hint from it? What type of matrix it is? You see the values are less than 1. Uh, do they show you some property? I mean, you should think about it because we are thinking of calculating the inverse, right? And calculating the inverse by doing the complete row and column transformation takes a lot of time, right? So, do you have something striking when you see this R matrix?
And these are skew symmetric matrices actually.
It is a. I'm not getting your voice. Can you just increase your mic or speaker volume? I don't know, but
Ma'am, is it skew symmetric matrix?
okay, it is. But how would that help in calculating inverse?
Actually, two elements are 0, 0. So
Mm-hmm.
I think we can find a determinant very easily of this.
Yeah, you can find a determinant. That's fine because the matrix looks relatively simplified. You just have to. So, can you calculate a determinant and tell me what is a determinant? That would give you some other hint also. Check the determinant of the matrix. Is it in row echelon form? For row echelon form, you should have. Uh, no, it is not, right? Because the second row does not like. What are the conditions for row echelon form? The first row has to have all the elements. Then in the second row, the first element should be left to be zero, and you should have any non-zero element starting from the second column, right? And then this goes till the last row, and then you have all the rows of zero. So it is not in row echelon form right now. See the determinant. What is the determinant that you're getting? Is it somewhat close to one? Yeah. Yeah, it is close to, it is one, right? So, uh, if the determinant is one, then do you get some hint? Okay, what is an orthogonal matrix? Okay, what is an orthogonal matrix?
Yeah, but if transpose is equal to inverse.
Yeah, transpose is equal to inverse. That is one of the properties of orthogonal matrix. So how do you identify if the matrix is an orthogonal matrix? See, this is very important because we are going to deal with rotation matrices now and then. So this is really important. Uh, so how do you identify if a matrix is orthogonal? Okay, before we move to orthogonal matrix, let's discuss what are orthogonal vectors.
I think actually matrix into its transpose is equal to identity.
Matrix into transpose is equal to identity. I think that is still the definition of the or the property of orthogonal matrix. So if you say this, that R into R transpose is identity, you are basically saying this inverse thing only. So the inverse is equal to R transpose. Just I think we have some answers in the chat. And orthogonal matrix is a square matrix or orthonormal meaning there are perpendicular. Yeah. So I don't know why it looks like it is copied from Wikipedia or Gemini, but it's okay. So what I'm really talking about is okay, okay. So, yeah, right. Orthogonal matrix is a square matrix, and all the rows and columns are orthogonal to each other. Orthogonal to each other means what? Orthogonal vectors means what? If you take any vector, let's say take a column vector. So, let's say I take this column vector. I'll show you. Let's say if I take this column vector, okay, and I take this column vector, okay, and take a product, dot product, what would I get? Wouldn't it be zero? It would be right 0.866 into minus 0.5 plus 0.5 into 0.866 plus 0 into 0. So it is going to be 0. So orthonormal vectors are the vectors in which if you orthogonal matrix is the matrix in which if you multiply any two rows together or any column, two columns together, you are going to get the result as 0. Okay. So this is the reason why it is orthogonal. So take the dot product between any two vectors, you're going to get it to be 0. Be it column wise, be it row wise. Alright, I hope this makes sense. So moreover, it is not just orthogonal, it is a special case, orthonormal. Okay. It is orthonormal, and this is orthonormal only because if you take the, like for example in a row, if you are going to take the magnitude of a vector, or in the column you are going to take the magnitude of the vector, you are going to get it to be 1. So essentially if you have the vector magnitude to be equal to 1, it is going to be an orthonormal vector. Okay. For example, if these terms were multiplied by 2 from before only, you had not done anything, this was something 1.6, the other term was 1, the magnitude of a position vector you would not have got that it is 1, right? It would have been some other quantity, something more than 1. Because you are getting it to be 1, it is orthonormal as well. If it were not equal to 1, then it would have been orthogonal. Okay, so orthonormal is just a special case of orthogonality. Okay, so one of the most important properties of these matrices, so my point is this is an orthogonal matrix. So you should know how to identify orthogonal matrix. If you identify na that it is orthogonal, you're not going to calculate the inverse. You're not going to find the determinant, and you're not going to calculate the inverse by doing adjoint, transpose, all of these things, calculating minors. We don't need to go through anything, because if it is, we have identified that it is orthogonal matrix, you can directly like write R inverse is equal to R transpose, and it's done. It's that simple. So we can write y is equal to R transpose x. Now the calculation becomes fairly simple. Just put the terms over here. Minus 0.50, 0.5, 0.8660, and then 001. Multiply it with 1, 2, and 3. And hence you get what is y. Please tell me the answer.
First option.
First option. Okay. Yeah, this is correct. Very good. 1.866, 1.232, and 3. So this is the answer. Okay. I hope this is clear. See, if you were not knowing that it is an orthogonal matrix, or in this case it is an orthonormal matrix, if you were not knowing, then you would have gone through a tedious process. We did not go through. And the rotation matrices are already orthogonal matrices. So never ever you need to calculate the inverse. It is just going to be R transpose. Okay. Okay, now let's move forward. Okay, find the rank of the matrices given below. What is the rank of a matrix? How do you define the rank of a matrix? I hope everyone has gone through linear algebra course, where you study about linear dependence, linear independence. So from there we have this concept of rank coming up. Now can anyone tell me what is rank of a matrix?
Ma'am, number of linearly independent rows.
Yeah, or rows, any one of them. So what is the number of linearly independent rows or columns that you have? If you have some linear dependence between them, then you get a reduced rank. Okay. So, uh, uh, so if this is the matrix that you are given, how would you find the rank of the matrix? I mean, just looking at it, we do not get a sense, right? That if it is linear dependent or linear independent. For example, if I give you a matrix 1, 2, 3, 2, 4, 6, and let's say something it is 7, 8, 9, then you can easily say that okay, this is a very easy question, that both of these are linearly dependent, so the rank is reduced by 1 and the rank of matrix is 2, right? You will directly say this. But, and how do you uh, come to this conclusion? You definitely multiply this R1 into 2. So you take R2, replace it with R2 minus 2R1. Right. So you make this whole row to be equal to 0, and then you say that the rank is reduced and all of those things. So in this matrix, how we'll do? I mean, we are going to follow the same method only. But can anyone tell me the operations that we are going to perform?
Ma'am, we can obtain the third column if
Uh-huh.
we multiply in the second column by 2 and subtract the first column. It will be the third column. If we multiply in the second column by 2, so the first element will be 4 and 4 minus 1 will be 3. Similarly, 3 into 2, that is 6 minus 2 is 4, and 5 into 2 is 10 minus 3 is equal to 7.
Okay.
So
So do you
third column,
get the two rows to be same?
yes ma'am. So
Okay.
third column can be obtained by the multiply by 2 in second column minus first column.
Okay. Yeah, that is also one of the ways. So we can go using various ways. We just have to come to a point or converge at a point where we just find that, yeah, these are linearly dependent. So we need to go there. So what I usually prefer is just one second. What I prefer is converting everything to row echelon form, because that is the best thing you should do to get zeros in the bottom, and if you have some further calculations to make, you can make that. So I'll proceed in that manner. Okay, so I'll use elementary row operations. I think this is class 11th concept, right? Okay, so let's say on this matrix we are going to apply, let's say we replace R2 to be R2 minus 2R1 and R3 to be R3 minus 3R1. What do we get? This remains the same. 2 minus 2, this becomes 0, minus 1 and minus 2. 0, minus 1 and minus 2. Okay. Now, since we have got this, we see that R2 and R3 are same. We will just use one more transformation. R3 is R3 minus R2 to bring it to echelon form. And it would be 1, 2, 3, 0, minus 1, minus 2. And this would be 0, 0, 0. Okay. So, what is the number of non-zero rows? 2. Rank of A is 2. Okay. So do not see that, okay, this looks like it would not have any dependency in between row and columns. No, it is not always the case. So I think we should always try converting the matrix to its very, I mean, to the echelon form. and then we should see that, okay, how many. I think it is not necessary to go to echelon form. You can always find it in other ways also, but yeah, this is a cleaner and more strategic way in which you proceed. That is why. Okay, I hope this is clear. Okay. What condition on B1, B2, B3 and B4 make the following systems of equations solvable? Do you know what is augmented matrix? Does anyone know what is an augmented matrix? I mean, you have an equation called AX is equal to B, right? If I say I write a matrix such that A and B are together, it is called augmented matrix. Okay, so whatever operations you perform on A matrix, row operation or column operations, you are supposed to perform all of them on B matrix as well. Okay, so we'll be doing the same thing. So what we actually want is, we want to have some condition B1, B2, B3 and B4 to make the system of equations solvable. Solvable as in we get some number of equations. So from the options also you can guess that we want to have some set of equations coming up from the this matrix. So how will we will get that? We should have something in mind, so that we convert it into echelon form and we reduce the number of equations, then we get a few number of equations only. But any operation that you apply on A matrix, how is it going to be applied on B matrix? So for that you need to have augmented matrix, that okay, whatever I am doing to the A matrix, I should be doing to the B matrix as well. So for that, you can bring the augmented matrix together, and then you can perform all the row operations and column operations. Okay. So see what we'll do. We will write the augmented matrix first. It is 1, 2, 2, 4, 2, 5, 3, 9, right? And then we'll have B1, B2, B3, B4. Then we can try to convert it into echelon form. How do you convert it to echelon form? Uh, we can try to reduce, make as many number of zeros we can. Okay, so what we'll do is, we will write we'll replace r2 by r2 minus 2 r1, so that would give us zeros directly, right? Then we'll try to replace r3 r, and then r4 also, r4 minus 3 r1. Please keep solving, it would be very helpful to you, because mathematics you'll always need. And if you are doing robotics, I'm sure you're doing control as well. For control, you need to have a very strong grasp on linear algebra. It is a must subject. Okay. We have this 0, 3, 0, 1, and this would be 0, 0, right? And we have to do the same thing here as well. It would remain B1. It would be B4 minus, sorry. It would be B2 minus 2B1, B3 minus 2B1, B4 minus 3B1, right? Now we want to reduce it further, because we still do not have the options coming up. Okay, so the options that we already have match none of these. Let's say if we write the try to find B4 is equal to 3B1. We don't have any options attained till now. So we'll move one step further. What we'll do? R3 ka 1 by 3 R2. Let's do this. So that we have even more simplified version. So 2 rows become 0. Sorry, this is an augmented matrix. This would remain B1, right? This would be B4 minus 3B1. Uh, just a second. No, no. We can't go directly. Can anyone tell me what would be the next operation? What we should do?
Ma'am, last row, second number is not 0, right? 9 minus 3 into 2 is 3. R4.
Yeah. Thank you for correcting. Yeah. And I think there is a problem here also. Right? This should also be 0, na? R2 minus 2 R1. Yeah. Thanks. Okay. Once we have come here, what we should do? I mean, we have this 0 0 already coming up. Okay. And if we try to get everything in echelon form, we know that we should have zeros coming in the last row. So let's proceed with that. So we'll make a swap between R2 and R4. So it would be 1 2 0 3 0 1 0 0, and here it would be B1 B4 minus 3B1 B3 minus 2B1 B2 minus 2B1. Please check once. I think I've written things correctly. Okay. Now we want to move one more step further. We want to make this one also 0, so that we have two equations coming up which we need of some constraint type. So it would be R3 minus 1 by 3 R2 would give me this equation to be this thing to be 0, right? So if I write now, it would be 1 2 0 3 0 0 0 0. It would be B1 B4 minus 3B1 B3 minus 2B1 minus. See, the option that we have has to do something uh, taking this second term as well. So this comes here. B4 minus B B4 minus 3B1, and here it is B2 minus 2B1. Okay. So from here what you can get? These two things. This and this. Check if both of these are available in your equation, in your options.
An option.
Sorry?
And the second option.
Yeah. Second option has both of these things. So when you tried to reduce it into echelon form, you got two set of equations already coming up and you could directly write. Let's say you would have performed some other arbitrary row operations, you would have ended up here. It's not that you would have not, but you would have made many substitutions, tried to find out the relation using the first and second row as well, and then you would have come here. So this question was only framed like that when you are proceeding with echelon form, you get the answers fast, because that is the standard way of doing. Okay, I think this is clear. Okay. All right.
Ma'am, can you please show the options?
Yeah. Okay. Now, okay. If there is an A matrix of dimension m cross n and it has a rank R. So, let's say we have an equation Ax is equal to B and it has no solution. What inequalities must be true between M and R? What should be the rank of the matrix and how can it be compared with M and N if the matrix has no solution? What is the meaning of no solution? When do we say that the system of equations have no solution? Okay, can you tell me? 2x plus 3y is equal to 5. 2x plus 3y is equal to 11. Can you tell me, do they have, how many solutions do they have?
And they have no solution.
They have no solution. Okay. Okay. I have another set of equations. 3y is equal to 5. Uh, okay. No, you already know this unique solution thing. Okay, that's okay. So this has no solution, right? Because none of the xy pairs would be able to satisfy both of them. Okay. So let's say we have a matrix. Now, if we write a matrix which has ax, which is in the form of ax plus b, okay, and then, so what it would be if I write the same thing, 2 3, right? It would be x and y. It would be 5 and 11. Let's say it has a rank m cross n, which in our case is 2 only, both ways, and this has a rank r. Okay, then what is the rank of this matrix? 2 3 2 3. It is 1, right? It is rank deficient, so it is 1. So this 1 is less than m, less than n. I mean, rank of of any matrix can be less than equal to m or less than equal to n only. It can never be more. This is a conceptual thing. Now, if it has no solution, that means these two rows somewhere should be equal, but on the other side, you'll not have the equality. So we need to compare R with M, R with N, and compare M and N. So what do you think should be the answer? This is just an example case 2, 3, 1 which I took. But what do you think should be the answer to this question? This sort of matrix that would be involved in this question will look of this, will be of this type only. If it is not a square matrix, definitely M and N would be different. So I mean, can you guess what can be the answer? And I'll leave this question for your homework as well, but I need to see your response. B. R is less than M. R is less than equal to N and M is greater than N. Can you tell me on what basis you were able to compare M and N? I mean, do you have a basis for comparison of M and N?
And how can we compare M and N?
Sorry?
I think we can't compare M and N process number 3.
Yeah, we cannot compare M and N because uh, I mean, what is the nature of a matrix has or what is the dimension of a matrix has nothing to do with how both of the dimensions are related to each other. They can only be compared with the rank of the matrix. So I'll tell you the correct option is C, and please take it as an homework as well to come up with an answer to this question, because uh, yeah, please check this. You can also, one approach to find out the answer is also to go through echelon approach. Because if you go through that, then you'll see that one of the rows becomes zero, and then you find the rank of the matrix is less than what is the number of rows and what is the number of columns. But there is another thing that comes into picture is that whenever there is a case of non-square matrix, so how the rank is defined, and when the rank is defined in that way, then how do you compare it with MNN? So please look into this. This is your homework. Okay. We'll move to the next question. If you want, take a screenshot of this question, and we'll take this up again in the next class. And I want answers from your side. Okay. I'll move forward. Okay, I just explained the orthogonal and orthonormal thing. So you're supposed to find out which of the vectors are orthogonal and which pairs are orthonormal. Sorry, which are orthogonal and which are not orthogonal. So any of the four options would be true, and you know now how to check orthogonality, right? Just find the dot product between two vectors. If it is zero, it is orthogonal. If it is non-zero, it is not orthogonal. So I want you to solve this, and please let me know the answers. It's a very simple question.
And option number 4.
Option number 4. V1 and V3 are orthogonal, and V2 and V3 are orthogonal. Okay. V1 and V3. Yeah, correct. D is the correct option. Does anyone have problem in this? Should I solve this, or it is well understood? It's just the dot. Okay, okay, okay. Okay, so I'll solve directly with the answer because I want to clarify that why fourth one is the correct answer. So let's take V1 and V3. Okay. Okay. Let's take V1 and V3. What we'll do is we will find a dot product of both these vectors. Okay. So if you want to find out the dot product of V1 and V3, so it is 1 into 1, which is 1, 2 into minus 1, plus minus 2 into minus 1, plus 1 into minus 1, right? 1 minus 2 plus 2 minus 1, all cancel out to be 0. Similarly, if it look for V2 and V3, it would be 4 into 1 plus 0 plus 4 into minus 1 plus 0 is what? Both will cancel out and you will get 0. Try this for other pair of vectors. You won't get them to be equal to 0. Okay, and they won't be orthogonal. I hope this is clear now. Okay. Okay, we'll proceed with the next question. Yeah. So, uh, what is, when is a system called linear? Or what is linearity? How do you check linearity of an equation? Do you know the principles of homogeneity, additivity, homogeneous systems of equation? Okay. So if we want to check the linearity of the system, the first thing that we need to do is we need to check if it satisfies both of these transformations. If it does, it is linear. If it does not, it is non-linear. Okay, so let's say we want to check the first option, if it satisfies both of these or not. We just want to check that if both of these things are being satisfied by what number of options. Okay, so let's say I'll show this to you for the first one. Please move on with the second one. Okay, so let's say for the first one, TV is given by V by mod of V. Okay, TW is given by W upon this, right? Now I also want to know what is T of V plus W. So how would you write it? You would write it as V plus W upon mod of V plus W. Okay. Now let's compare. We want to check if TV plus TW, यहाँ पे a question mark, to TV plus W. So you'll write it then V upon mod of V plus W upon mod of W is equal to V plus W, question mark again, upon V plus W. Okay. So V upon mod of V, W upon mod of W, again question mark. We can't separate this mod, right? I hope this is clear. V upon V plus W. Can you tell the LHS and RHS both are equal or not? Sorry? Are they equal?
No, ma'am, they are not equal.
Right. So both of them are not. Yeah. So it does not satisfy the this transformation, the first transformation. Okay, so it fails for this. You can also check the second transformation, in which T of V is given by V upon mod of V, right? Norm of V actually, not mod. Okay, so if we want to find out 2TV, what it would be? It would be 2 into V by norm of V, right? But uh, it was T of CV is equal to CTV. Okay, CTV we have done. T of CV, yani T of 2V if we want to do, what it would be? 2V upon norm of 2V. So if you try to compare both of them, are they equal?
No, ma'am,
Then
they are
yeah, they are not equal.
already given all options. A fails.
Which option?
Ma'am, actually, in all options, it is given A fails for T2V is equal to 2T TV. So there is no need to check this according to option.
Okay, according to option, you're saying that you don't need to check this, right?
Yes, ma'am.
Okay, yeah. So it fails for this as well. So you can check for all the four options, which for all the like A, B, C, D are the four things that are given to you, and then you can say that which of the following options is correct. I mean, you need to check the transformation for all of them. Can you try it for the second one? It is very simple.
Maximum B satisfied all the conditions.
Which satisfies all the conditions?
Yes, ma'am.
Can you raise your voice? I'm not able to hear you properly.
Actually, the second part B is T of V is equal to V1 plus V2 plus V3.
Yeah.
So for the sum, it will satisfy both the conditions.
Okay, it will satisfy both the conditions. All right. Okay. You can check for the other two options also. Does anyone have any confusion? If you have, please tell me. Else, I am assuming that all of you are able to solve, given I have solved the first this option or the first problem.
Yes, I'm doing.
Okay.
And option 4 is correct.
Option 4. Are you sure this D satisfies all the conditions?
Actually, ma'am, in the second part, I'm confusing.
Yeah,
I
check
believe
the
it's
second part.
the first condition, but second, I'm still confused.
Yeah. So I'll solve the D. So for the whole set of class, the first A option we already looked at, right? V upon norm of V does not satisfy both of them. Now in the B part, it's V1 plus V2 plus V3. If you take W, TW, it is going to be W1 plus W2 plus W3. Now if you add all of them, it would be V1 plus W1 plus V2 plus W2 plus V3 plus W3, right? And if you also like combine both of them and write, then also you are going to have V plus W, all of them together. So it satisfies. Now in the C problem, is V1 plus 2V2 plus 3V3. So it is basically uh, a set of numbers that you have together. Now what we are going to do is TV is V1 plus 2V1, 2V2 and 3V3. Similarly, you write TW to be equal to W1, comma 2W2, comma 3W3. You add both of them. Whatever you get after the addition would be equal to TV plus TW being written together. Alright, so the corresponding numbers from TV and TW would add up, and hence you will find them both of the things to be equal. Similarly, it would be same for TCV as well. If you face any problem, do let me know. Uh, Else I'll directly solve the D one, which can be problematic. So yeah, D is largest component of V. Okay. Okay. Now, okay. Let's say we can even check this with the help of example. It is not always necessary to do it in terms of variable. You can always check it in terms of example, and if one example violates it, then you know that okay, it is not going to be the general case. Okay, because it is taking component. No, see, component is can be I cap, j cap, k cap. So you can find out any x component, you can find out any y component, and then you say that you're going to add both of the greatest component, and it is going to be equal to the sum of them. It's not going to happen, so we'll see that. Let's say I take an example. V is equal to 1 to 1, w is equal to 1 0 10. Okay, if I write tv plus w, what it would be? What happened? Okay. Okay. So TV plus W is going to be transformation on this to 11, right? So it would be 11 because the largest component is 11. Whereas if you write TV plus TW, it is going to be 2, 2, sorry, individually. It is going to be 1 to 1 पे ट्रांसफॉर्मेशन लगाया प्लस 10 पे ट्रांसफॉर्मेशन लगाया. What will you get from here? You'll get 2, you'll get 10 from here. It would be 12. So 11 is not equal to 12. T V plus W is not equal to TV plus TW. Okay, this is where we lose this. All right. Okay. Now, just a second. Okay. So I think we are done with this maths part completely. Um, Before that, we'll solve some questions from the first week also. So these are very simple questions which have already been taught. So I think we can proceed much faster. So if you remember from the first lecture, the word robot was first used to depict a humanoid or mechanical man. In Czech language play, Rosum Universal Robots, this play was written by whom? Do you remember from the lectures?
If you move,
Asimov.
no, I think it's Carol Capek.
Yeah, it's Carol Chapek. Oh, yeah, right. Okay. Industry 4.0 deals with cyber physical systems that interconnect what? I mean, this is Industry 4.0 only going on. What are we seeing actually? It's an easy question. D. Yeah, D. Machine, humans, and AI. Good. Okay. To be called a robot, a system should self multiply, move around, speak, or use cameras. Yeah, good. Okay. The degrees of freedom of a revolute and cylindrical joints are what? You have read this. Tell me what is the degree of revolute and cylindrical joint? D, you want to say 2 and 1. For revolute, it is 2. Revolute is just moving along one axis, no? So it has just 1 degree of freedom, right? So, okay. Let's see. This is a revolute joint, right? It would move like this, around this, right? For cylindrical, what is the case? What is a cylindrical joint? You have a joint like this, and let's say you have this. Yeah, up and down is true. So up and down is 1 degree of freedom, right? Up and down is along an axis. So it is 1 degree of freedom. So you're talking about this up and down. So it is one only. One more, what is there with cylindrical? It can also rotate.
Then option B.
Sorry, option
B, second option, 1 and 3.
1 and 3. Why 3?
Cylindrical.
Cylindrical joint is only able to move in this direction, which means it is able to move along this axis and it is able to move along this axis. So it is just 2, right?
Okay, third option.
Yeah, C option. So we don't consider up and down as different because it is along the same axis. So, so it can move in this direction, it can rotate in this direction. Oh, if you are confused with the arrow, then we can have the arrow like this also. So it is 1 and 2. Okay. Okay. A spherical ball is kept on a flat table. Huh? A robot is expected to pick up the ball with a gripper and place it at another location on the table without pushing or dragging the object. What is the minimum degrees of freedom the robot should have to do the task? There is a 3D space in which there is a spherical ball kept on the table. Now you need to lift that ball and pick it at some other place. put it at some other place. So what is the minimum number of degrees of freedom you need?
Ma'am, two, is it two?
Two? How two? How two would suffice?
I thought just pick up the ball and
But you have to navigate in 3D, right? For navigating in 3D, you would need 3 degrees of freedom, no? You should be able to move along the x-axis. You need to be able to move along the y-axis, and you need to be able to move along the z-axis. So you need to move along all the three axes. So I think you
three
will
spots.
need three. See, we might need more if we uh, want to look for gripper orientation as well. But we do not need. We just want to navigate in 3D. So we must have at least X, Y, and Z motion. Okay. And why gripper we are excluding? We are excluding gripper because the ball is a spherical ball. So you need not maintain some particular orientation to grab the ball. It can be grabbed from any side. So we don't need that. So we would just need three. Okay. Okay. The work volume of a cylindrical robot having two prismatic and one revolute joint is what? This is mostly an imagination kind of question. I want to listen to your intuition at least. What do you think? There are two prismatic joints. Okay, I would clarify it more for you. The two prismatic joints are okay. Obviously, they are not along the same axis, right? It would be along some other axis only. If it is along some other axis, how it would look like? Or what would be the volume? I can draw a small figure for you. Let's say this is the base of a robot. Okay. This is the first prismatic joint, and you're able to move from here to here. This is another. From here you have some this motion is also possible because there are two prismatic joints. Okay. And here let's say you have a
Ma'am, option 2.
option 2 hollow cylinder. Okay. That's the right option, but can you give me some clarification?
The combination of movements result is in a workspace
Uh-huh.
that that resemble a hollow cylinder, where
Yeah.
the robot can reach a point within the cylinder volume while also rotating around its center axis.
Okay. So it is like this if this is a revolute joint. Okay. So it is going to spin, right? So since this is a prismatic joint, this is a prismatic joint, this one. I would change the color. Yeah. This is a prismatic joint. Matlab we can definitely move up and down in this direction. So this height is something we can always change. Since this is a prismatic joint, we can also change the length in this direction. Okay. So this is definite that we can change the length in both of these axes. But then it appears to be in a plane. So something has to be done with this revolute joint as well. Now, this revolute joint, this revolute joint will help us to place the end effector position rotating around in a circle, right? So you have this planar structure coming from the two prismatic joints, and then you have this revolute joint that helps you span a circular motion in the around one of the axes. So it helps you get a hollow cylinder. Now, one more thing, this cylinder is not limited to just this radius. It can, the end effector can also come here, right? It won't always have to be there. So it can come up until here also, and then it can move. So it is also always going to be a hollow cylinder with a different variations in dimensions. All right, so this is the correct answer. Okay. The position of a point in 3D is represented by three coordinates x, y, and z. The orientation of a rigid body is represented by what? How do you represent the orientation of a rigid body?
Option C, 3 into 3.
What is that 3 into 3 matrix? What is the name of the matrix?
3D shapes.
Sorry? So you have already seen it in your lecture. It is rotation matrix. Okay. So the position of a point in 3D, the orientation can be represented with the help of rotation matrix. So you saw already, right, that when you have a point in space in some coordinate system, and then you shift the frame, then the coordinate point can be represented in that frame as well. It's just that you have to apply the transformation using this rotation matrix. That's all. Okay. Now, determinant of 3 cross 3 rotation matrix is equal to what? Okay. So this rotation matrix is orthogonal matrix. If it is an orthogonal matrix, determinant of this matrix is going to be 1 only. But you can also check, do verify. Let's say I have a rotation matrix about z axis, okay? So it's cos. Can someone remind what is the rotation matrix about z axis? We saw in the beginning of the lecture today. Okay, it's cos theta minus sine theta, cos theta 0, 0, 1. Okay. Now find the determinant of this matrix. We'll get it to be 1. All right. So the determinant of rotation matrix is always 1. Cos squared theta plus sine squared theta. Okay. You can check it with other rotation matrices as well. Now we can solve this problem too fast. Please get ready with your notebooks. This is a very simple example, and it has been taken in lecture as well. 0? How do you get 0? It's cos square theta minus sine square theta. That means it is cos square theta plus sine square theta. So it is 1, right? Yeah. Okay. Now, this is your point in B frame. So a frame B is rotated by 30 degree about x axis. So we need to take into account Rx. About a fixed frame A. If the coordinate of point P in frame B is given by this BP is equal to 0, 0, 1, then what is its coordinate in frame A? We are supposed to find this, right? So, you know, AP is equal to R. We need to find what is in A. So, we need to go to frame A from frame B. Okay. So, AP can be given by, just write the rotation matrix over here. 1, 0, 0, 0. What happens for X? It is cos 30 degree minus sine 30 degree, sine 30 degree, cos 30 degree, right? And this is 0. This is 0, 0, 1. Yeah. Please solve this and tell me the answer. AP is equal to what? Which option is correct? It's a very simple question. I hope you're able to read my handwriting. Minus sine, and this is cos. Please tell me the answer.
Ma'am, fourth option.
Fourth option. Okay. Yeah.
Option C.
Yeah. So D is the correct option. It is 0 minus 0.5, 0.866. You should get this in your answer. Alright. Now we'll move to the last question. This would also involve translation. Okay. It is almost similar question, just with translation. So a frame B is rotated. Who was the one who was having problem in solving the assignments in the beginning? I think he has left. Okay. Okay. So a frame B is rotated by 60 degree about Z axis. RZ use करना है of the reference frame A and is translated by 100 units in X, Y and Z direction of A. If the coordinate of a point in frame B is given by this, what is its coordinate in frame A? Again, it is just, now just the thing is that translation comes into play. So we'll be writing it a little differently. Let's write the things first. BP is 111, right? Delta X, delta Y, delta Z are, sorry, 1 comma 0 comma 0. Now we have to find AP. You have already seen that we have 1 always coming up just to maintain the uh, square nature of the matrix, and to include the translation, make the matrix invertible, just to make the thing solvable. This one is there. Into this is a transformation matrix from B to A, and this is BP and 1. Now this is given by rotation matrix from B to A, which is about Z by an angle of 60 degree. Then this is delta X, delta Y, delta Z, 0, 0, 0 and 1. I'll separate it. Okay. Now you can write the values here. If you write the rotation matrix, it is cos theta, cos 60 degree, minus sine theta, minus sine 60 degree, sine 60 degree, cos 60 degree, 0, 0, here it is 1, here it is 0, here it is 0. Delta x, y, z is 1, 1, 1. Sorry, it is 1, 0, 0, right? Yeah, it is 1, 0, 0. 1, 0, 0. Here it is 0, 0, 0 and 1. Multiplied with 1, 1, 1, 1. BP and 1. So whatever you get would be the value of AP. Can you solve this and tell me what do you get in AP? I'll show you the options also once more.
The second option.
Which option?
Second.
B.
Yes, ma'am. B option, second option. Second option.
Okay. Yeah, it is correct. So B is your correct option once you solve this. Similarly, if it were the case that you were given A already and you were supposed to find B, then you'll have to take the inverse. But you can only take the inverse of rotation matrix as um, R inverse is equal to R transpose and all. For translation matrix, you are supposed to multiply it with minus R transpose. So we already saw that in the beginning of the lecture. It was a part of the slide only. And then you can take the inverse and solve it easily. Okay, I think that makes sense. Okay,
Thank you, ma'am.
so this was the first week. In the next week, we are going to have DH parameters. We'll be solving the questions related to the DH parameters. Please go through them. Also look at all examples that you can already see. I am sure I have seen that there are already a couple of examples covered in the lecture, but still you should have a good practice of it because that is one of the widely used conventions in robotics, and we must be through with it. Okay. Okay then, we'll end the lecture today and we'll meet next Monday again at same time. Thank you.
Thank you, ma'am. Thank you.